In this video, we will talk about caches. Caches is a system spending a lot of time moving information from one place to another. For example, original Hello program on disk, copies Hello program on main memory, copies Hello program on processor. So, these steps can be caches. Another example, original program or original data string hello world on disk, copies data string hello world on the main memory, copies data string hello world on display device. So when you look at easy examples on the screen, we can imagine data or program can move from one place to another, right? So that's related with caches. So if you want to know more information about caches, you can check the subchapter 1.5 caches matter. So why did caches matter? If you consider Internet Explorer usage every day, even though we connect to YouTube or other Facebook, the social network service in our local computer, even though these servers, original servers, were located in US, right? But the speed is not slow. We can experience the contents and the music, the other the multimedia, the data can be played in real time, right? These are related with the caches. For example, the YouTube content or other multimedia, many kinds of content were stored in Korea server too, right? So original data for the first time or existed in the US, but whenever most users played the high-ranking YouTube content or multimedia services, the YouTube Korean server temporarily stored the high-level ranking contents in the Korean YouTube server. So these also are related with the caches, all right? So even though we go to Naver or Google every day, so many the advertisement related videos were stored in our local area, such as the specific disk, and then every day the operating system or Internet Explorer reused the stored the similar or same the parts of the video to reduce the slow playing, right? So that is also related with the caches concept. So whenever you met or you will meet the similar concept to reduce the playing speed or to reduce the overhead from the one place to the nearest place, we can reuse the caches concept sometimes, all right? Okay, so as I mentioned about the memory concept in a previous video, we should learn the memory hierarchy as you can see on the screen. So please take photo these slides and you can write down this concept and figure in your own notes and periodically check your photos of cell phone as well as your the personal writing note. Okay, so this figure shows an example of a memory hierarchy. So whenever the smaller the speed is the faster and they can calculate or use the data very quickly. So the level 0 is red, So that is the abbreviation of the register in CPU. So CPU registers hold words retrieved from cache memory. So rack SLAM is the higher level, and the second is the SLAM. It is the L2 cache. So L1 cache holds cache lines retrieved from L2 cache. Similar procedure, L3 is the below of the L2. It is still SLAM related with the name of the memory. So L2 cache holds cache lines retrieved from L3 cache. These are refer the main memory, DRAM. Alright? So as we can check or learn the main memory location of the hardware components, main memory is the another name is DRAM, and SRAM are related with the CPU part. Okay, so CPU part refer DRAM in L4 level. Okay, and the after that the local disk is referred existed the below part of the DRAM. So main memory holds disk block temporarily retrieved from the local disk. And have you ever used the USB disk or cloud or web service? These are related with the remote secondary storage. Another name is distributed file system. So local disk holds files retrieved from disk on remote network server. So as you can see on the screen, the top level is small and faster than below levels, right? So whenever we go to the bottom part, it is large and slow and cheaper than the higher levels. All right. So please memorize the concept of the memory hierarchy and the SRAM, DRAM, local disk, and distributed file system concept. Okay. So SRAM is the abbreviation of static. Okay. So static random access memory. DRAM is abbreviation dynamic random access memory. Okay, so dynamic means flexible and can be changed periodically or randomly. All right. Okay. So caches serve temporary staging area for information that processor is likely to need in the near future. It can deal with the processor memory gap, and caches can exploit locality, the tendency for a program to access data and code in localized region. So locality is related with the programming concept. So have you ever heard about the for or while reserved words with the Python or other language? Similar to the Python or other languages, we can also learn the for or while repeated reserved word in C programming language soon. That means locality. So we can repeat the specific part of our whole code, and we can repeat the parts locally, right? So we can get the proper results based on locality. Okay, so program can access the partial parts of the whole code locally and reuse the specific parts repeatedly. So that means localized region. Okay, so we will cover caches concept in detail in chapter 6, so don't worry about it. So if you check this figure in the screen, CPU hardware chip is composed of cache memory, register file, ALU, bus interface, as we learned already. Okay, so the bus interface can interact with the I/O bridge with the system bus, and I/O bridge can interact with the main memory with the memory bus. So each two components has the each own the named bus. So they are separated very properly. Okay, so if you are interested in the chip design or the optimal bus chip lines, the architecture, you can um, uh, consider the electronic department parts in future. Okay, these are only related with the hardware concept, but our lecture is the integrated concept between software and hardware, as I mentioned. So it is a little different. Okay, so cache memories is related with the PC part. If you compare the previous figure with um, the current page, okay? Okay, we will move to the subchapter 1.6. So title is Storage Devices from Hierarchy. Okay, so processor, another name is CPU, cache, and memory. So this notion of inserting a smaller, faster storage device, such as cache memory between the processor and larger slow devices such as main memory, turns out to be a general idea, right? So we can reuse this general idea to our own domain or another idea, okay? Such as the YouTube server of US and YouTube server of the Korea, as I mentioned. All right, or if you are accustomed with the use the Internet Explorer every day, such as Naver or Google, even though you try to download all content such as the video content, so many kinds of multimedia in Naver, but the speed is not slow because our local disk have the previous or already downloaded parts in our local area, similar to the cache concept. So only new data of the Naver or Google server download the new parts whenever users click or to go to the Naver main page. All right, so these are related with these general idea. The main idea of the memory hierarchy is that storage at a level serves as a cache for the storage at the next low level. All right, for example, main memory is a cache for the disk. So that is the relative concept, not absolute concept, right? So main memory is a relative cache, relative and temporary cache for a disk, the next lower level, right? So please memorize and fully understand this general idea and concept. So please take a photo this slide too with your phone and periodically refer and memorize the native English writing for your future. Okay? So for example, if you want to be a researcher or co-worker in the American or foreign company after graduation, or if you go to the graduation or PhD course in US or England or other English language another countries, you should be interviewed these concept in English, right? So in this case, if you are familiar with the native English writing with the computer structure, you can reuse and the utilize these the natural and the good English writing. Okay, so you can explain the computer structure concept with these English grammar and sentence and the concept too. Okay, so finally we should move to the operating system concept. Operating system is very, very important because even though we already use the operating system such as Windows or Mac OS, but we did not know the exact definition and roles or functions of operating system in computer, right? So we should know what is the exact definition of the operating system and what is the function of the operating system. So please remember the definition and function of the operating system. When you look at the subtitle of this slide, the operating system manages the hardware. All right. So already I mentioned about the operating system function in the first week. So even though we already use the Internet Explorer, KakaoTalk, Putty, or other application programs, these are the higher level and is located on top of the operating system. So with the operating system, the many kinds of application program can use the hardware, the below part of the operating system. All right. So please remember these figure. This figure is very, very important. As I mentioned, many kinds of application programs were located on top of the operating system. But operating system and whereas the application system software, all right? So below parts of the operating system are hardware such as the CPU, namely processor, main memory, I/O devices. All right. So operating system can manage many kinds of hardware. Right. So operating system is similar with God, God. All right. So without operating system, we cannot use many kinds of application system. So it is very easy concept because before installation of the many kinds of operating system, for the first time we should install operating system such as Windows, right? So after operating system, many kinds of application program can be installed and meaningful, all right? So operating system is a layer of the software interposed between the application program and hardware. Or attempts by an application program to manipulate the hardware must go through the operating system, all right? So please remember two English definition, English sentences, all right? So similar to me, please speak in English these languages whenever you watch my video for yourself, because whenever you speak many kinds of good native English sentences, you can listen simultaneously, you can understand, and you can memorize with your brain, all right? So it is very, very important. So this figure shows the layered view of the computer system, all right? Primary purpose of OS can protect the hardware from misuse by runaway applications. It provides applications with a simple and uniform mechanism for manipulating complicated and often widely different low-level hardware devices. It can also provide the illusion that the program is the only one running on the system. It finally keeps track of all the state information, such as contents that the process needs to run and do context switch. these are very, very difficult and important concepts. So we will learn them in detail, repeatedly, and step by step from next video. So don't worry about it. All right. So these are related with the current value of the PC, register file, and contents of the main memory. So please extend previous short video, simple figure to this one. Please compare simple figure to the extend one. Application programs, operating system, and among hardware components, processor are related with processes. So different English words. So please compare the different English words. I will talk about the different things in detail, so don't worry about it. All right. My point, processor is CPU, the name of the hardware. However, processes are related with the software concept. So these are different, okay? And main memory and I/O devices are related with virtual memory. So what is the meaning of the virtual? It is not real. It is not physical part, right? So virtual memory concept were occurred from this figure, all right? And I/O devices are related to the files, okay? So these three components are related with hardware. Virtual memory and processes were more related with the software concept. Okay, so please memorize the simple figure and extended figure too. Okay, so please pause my video now and write down all English sentences and all figures in your note for your future and capability. All right, most students were not familiar with the hardware concept as well as new software concept. So I think chapter 1 is very important because through chapter 1 we can touch the all chapters roughly of the computer structure, and we can learn the important and main parts and terms and terminologies repeatedly before the future another chapters. All right, so application programs, operating system, processes, processor, main memory, virtual memory, files, I/O devices, hardware, memory hierarchy, new terminologies related with computer structure were acquired from first week to the current week, right? So please differentiate each terminology and meaning and fully understand each exact definition all by yourself, all right? Please take photo and repeatedly check your album similar to the previous week, all right? And processes were related with time concept. So process is a simple process, right? But these are plural parts, right? Not one, but many items, right? So processes can be separated with the process A, process B, process C, and so on, right? So many processes can be cooperated based on the policy of operating system, as well as hardware, the scheduling, all right? So for example, according to the time, process 1 can read and process B can content switch and come back to the process 1, and process 1 finishes the instruction based on the polish. All right. So when process A go to the process B, and when process B come back or return to the process A, we will learn them with the system programming and computer system contents with the C programming language in detail in future. So don't worry about it. Okay. So when you look at the process A, the new terms are read, disk interrupt, return from read. All right. So when you check the process B, user code, kernel code, user code, kernel code, and user code, right? So whenever the kernel code part, we can also check the context switch, right? So we will learn the meaning of the kernel and context switching part in future. Okay, so don't worry about it. Before going to the detailed parts of the process switching as well as the context switching and kernel parts, in this video, we roughly check the difference between process and processes for the first time. Okay, so we will move to the part for the first time. Okay, as I mentioned, process is operating systems abstraction for the running program. So not processor. All right, process is the program software part. All right, so multiple processes, that is the plural part, not single one, right? So multiple processes can run concurrently on the same system, and each process appears to have exclusive use of the hardware, such as process abstraction. Okay, so it is also a simple figure, but if you extend this figure, you should consider this another extended figure. All right, so process A is the shell process. Process B is hello process. We already made a hello file with the C programming language, right? So we can imagine, oh, process B is related with our own hello process program, right? But before execute our own hello process, as we already used, we used shell program, right? So shell process is related with process A, right? So for the first time, we can enter process part of the shell, and then we can finally execute hello our own process with process B, right? And with the kernel code, we can also use the hardware concept with the detailed or specific scheduling. All right, so these are related with a single CPU. So CPU is a related with processor, all right, not process. Okay, so traditional systems are a single CPU. Our own desktop and laptop, most them are single CPU. But if you extend another the service or product, such as the artificial intelligence applications such as AlphaGo or other game related with the server, these are mostly related with multiprocessors. So the number of the brains are multiple, alright? So the capability and the efficiency can be improved and cost are higher than traditional CPUs. But we will focus on the traditional system. That means we will focus on a single CPU. Alright? So in this video, we talk about the definition of the operating system and what is different between the process and processor. And we also talk about the number of the processes. All right. From next video, we will move to the more difficult and complicated parts of the example with the OS concept and multiple processes. All right. So please repeat this video for yourself and write down the exact definition and functions of the new terminologies all by yourself. And please memorize and fully understand them for your future and comfortably and freely select your own necessary parts of your note writing and take photo and paste to your trace flexibly in your own Word file, portfolio Word file, right? Someday I will recast the uploads of the assignment of our lecture, iCampus, and I can check your trace of each week, and I will comment and check your status of the understanding of my lecture, all right? Okay, please do not hesitate to ask anything about computer structure as well as your own concern, and connect me with KakaoTalk or message as well as email, all right? Okay, thank you for listening. See you next video. Bye bye.